Lesson 5 of Unit 2. Today we are learning about how to find the x-intercepts, also known as the roots, also known as the zeros, how to find those values of a polynomial without actually graphing. Okay? And we talked about this with quadratics in the Algebra 1 unit. If it is in factored form, we set each factor equal to 0 and we solve for x. That is it. Okay. So if we want to find the zeros, the x-intercepts, or the roots of a polynomial, all we do is we set each factor equal to 0 and we solve for x. And one thing you'll notice is that each x-intercept, root, or 0 has the opposite sign of its corresponding factor. And I'll talk to you what I mean about that as I go through the examples. So find the x-intercepts of the following polynomials without graphing. Okay, we know how to do this with quadratics. Now we could do this with other types of polynomials. We can simply take each factor. So for number 1, there are 3 factors. We'll take each of those and we'll set those equal to 0. Okay, so for number 1, for this one, I would subtract 4 from both sides. So x would equal 0 minus 4. For the second factor, I would subtract 2 from both sides. And I would get x equals 0 minus 2. And then for the third factor, I would add 1 to both sides. And I would get x equals 0 plus 1. And my 3 x-intercepts, my 3 roots, my 3 zeros are x equals negative 4, negative 2, and positive 1. Now, one thing I would like you to notice is that notice with the first factor we had plus 4, and then my x-intercept was negative 4. Okay. My second factor, I had plus 2. My x-intercept was negative 2. Third factor, I had minus 1. My third factor was positive 1. Okay, that is what I meant in the lesson notes by each x-intercept, root, or 0 has the opposite sign of its corresponding factor. In fact, that is a shortcut that you can actually use when finding the zeros when you have factored form. So on number 2, I don't have to go through the process of solving. I can just, I could say x plus 4. I can switch that to negative 4 and say x equals negative 4. I can switch plus 2 to minus 2 and say x equals negative 2. I can switch minus 1 in x minus 1 to 1 and say x equals 1, and then x equals change minus 3 to positive 3. And right there, in 10 seconds, I have my 4 x-intercepts from my 4 factors. Number 3 is a little different because notice I have 2x and 7x. First of all, the third factor is going to be the easiest one. I could switch minus 10 to positive 10 and make that x equals 10. Now, I can still use that same shortcut with the other ones, but I have to do an extra step. So, for example, I can switch plus 8 to minus 8 and say, instead of saying x equals negative 8, I'm going to say 2x equals negative 8. And for the second factor, instead of saying x, I can switch the minus 3 to 3, but instead of saying x equals 3, I'm going to say 7x equals 3. Okay. The difference with those two is now I have to actually go through and solve. So I have to go through and divide both sides by 2. On this one, I have to divide both sides by 7 to get the final answer. So x is going to equal negative 8 divided by 2, so that's negative 4. And then this one's going to be a decimal, x is going to equal 3 divided by 7. So use a calculator if you need to. And it comes out to approximately 0.43. So that's your second x-intercept, and your third x-intercept we had already found was 10. So finding the x-intercepts in factored form just got a little bit easier because we can now use that shortcut. Let's take a look at the cool down for tonight. All right. The purpose of the x-intercepts is that it tells you where the graph crosses the x-axis. So we have a polynomial here, and you should be able to find those x-intercepts quickly without graphing. Number 2, Jacob attempted to graph the polynomial below but graphed it incorrectly. Identify the error or errors in how Jacob graphed it. So if you find the x-intercepts, that should be those points on the x-axis where the graph crosses it. So you could probably figure out what the error is likely going to be. And that is it for lesson 5.